That's the
Good
masculineness.
He
afternoon,
just left
everybody.
again. So,
Good afternoon, ladies and gentlemen. Please, I would like us to invite as many people as we can to this call. We are about to commence. I would like us to send an invite to as many people
it's
as we
not him. It's
know
the woman voice.
will benefit from this call. And as we
Mm.
commence the webinar, I would like us to mute ourselves. Please. I would like
Mm.
us to mute ourselves, please, just to avoid distractions. Thank you. Thank you so much. While we wait for the commencement of this event, I would like us to reach out to as many people as we deem fit to be on this call. Please send your friend an invite. Remind them, those you have informed about the program, please remind them to be on this call. We're about to start the program. Thank you. For those just joining us, I would like to can we all hear me? For those just joining us, I would like to say this, that if you have friends, you have family, you have colleagues that you know would benefit from this webinar, please reach out to them. We're about to commence, and it will be an awfully sad thing for them to miss out on this, soon to be an insightful event. So please, let's all reach out to our friends and families that we know that will benefit from this webinar. Just send them a text. Hi, we're about to start the webinar. Please be on this call. Thank you all for joining. We'll commence shortly, very shortly. So we're currently waiting for the rest to join the call. By exactly 1:10 will commence. Thank you for your patience, everybody. So you have the opportunity to reach out to as many more friends as you can to be on this call. By exactly 1:10 p.m., this webinar will kick off. So please, let's do so before 1:10, and let's fix up our technical glitches if there is any, so that we can be focused, attentive on this call during the webinar. Thank you.
Factory in 2026. Is the new EGI less attractive than the old?
day, ladies and gentlemen. Please, I would like us to do a little activity. Can you go to the comment section and type where you're joining us from? Just say, hi, I'm joining from Lagos, Nigeria. Hi, I'm joining from Abuja, Nigeria. Hi, I'm joining from the UK. Hi, I'm joining. So let's get familiar with ourselves. Can we do that briefly? Just go to the comment section and then let us know where you're joining us from. Let us have an idea of who we have on this call. Who knows? We might just have the president on this call right now. So let's get familiar with ourselves. Let's do that quickly. Thank you.
Okay. Yeah.
And then please, can we mute ourselves? Thank you so much, Tolu. Tolu says he or she is joining from Calabar. Thank you so much, Tolu. We are happy to have you on this call. Can the rest of us do that shortly? And then can we also mute ourselves, please, to avoid distractions so that we can all hear ourselves clearly? Okay. Henry Dure says he's joining from Florida. Nice to have you. We are glad to have you on this call. Damilola Grace says he or she is joining from Lagos, Nigeria. Thank you for joining. Michael says he's joining from Abuja. Thank you, Michael, for joining us today. Favors Specular says he or she is joining from Lagos, Nigeria. Michael joining from Lagos, Nigeria. This is amazing. Can we get to more? We have over 20 people on this call. Hilary says he's joining from Nsukka, Nigeria. Thank you for being on this call, Hilary. We're glad to have you. We're glad to have you, Hilary. And then we'll just get 2 more and then we'll kick off. Okay, Daniel says he's joining from Poland. Nice to have you, Daniel, from Poland. Oluwafemi says from Ogun State. From Ogun State, Nigeria. Thank you for being on this call. We're glad to have you. Okay, so thank you, Blessing. Good day, ladies and gentlemen. I am Abisola Foluagoy, Superverge Tech brand ambassador. I'll be your host for today's event. Joining me on this platform is an amiable personality in the person of Excellence. Excellence, could you introduce yourself
Okay.
to the house?
Okay. Good afternoon, everybody. So I'm Excellence. I'm famous Excellence, and I will be your co-host. Thank you, Mrs. Busola, for introducing me.
Okay.
Okay. So without further ado, we're
Okay.
just going to introduce.
Yeah, Excellence, please hold on.
All right, ma.
Thank you, Excellence. Thank you, Excellence. That was excellent. Yes, he would bring up the guest speaker shortly, but before that, I would like to say that please, can we all hear me? Can you hear me now, everybody, please? Okay, beautiful. So I was saying earlier that we are delighted to have everyone on this call. I mean, we are overwhelmed to have pushed out this call for the webinar, and then we have people of this beautiful caliber on this call. Please, let's all celebrate ourselves. Let's celebrate ourselves by putting our favorite emoji in the comment section. We are honored to have you on this call. And then I would like to say that you being on this call is evident that either as a potential solar installer or as one already in the business, you want to grow in the world or in the solar installation world. You want to move from the beginner level to the advanced level. And even if you're already in the advanced level, you want to brushing up on certain aspects of the solar installation. I would like to also say that I mean, the word solar works, solar installation, solar panel installation, and the likes. It has become an essential aspect of the economy globally, either for individuals, for the public sector, and the private sector. And because of this cruciality, there has been an increase, a rapid increase in the demand for profound knowledge in the field of solar installation. Now, this is where Superverge Tech, came or comes in rather. Superverge Tech, has observed and noticed the high demand in profound knowledge for the works of and technicalities in solar installation. Hence, this webinar today. So I want you to be rest assured that either you have questions, whether you have questions that are yet unanswered, questions that you might want to ask, you want to brushing up your knowledge in the field of solar installation, you are at the right place. You are on the right call. Superverge Tech will answer your questions. Feel free to ask as many questions as you want to ask. There's no question here that is stupid or irrational. You will all be satisfied before you leave this call. Please celebrate Superverge Tech once again. Celebrate Superverge Tech once again. So shortly we'll be calling up the guest speaker, but then I would like my co-host, Excellence, to do the honors of calling up the guest speaker for the event today.
All right. Thank you very much, man. So thanks for the introduction on our webinar. So without wasting much of our time, I'm going to call on our guest speaker for today. Okay, so it's an absolute pleasure to welcome you all to today's solar installation masterclass. Yeah, at Superverge Tech, we are deeply committed to empowering individuals, businesses with knowledge, skills needed to embrace sustainable solutions. So for our speaker today, as the CEO of Superverge Tech and the founder of Superverge Tech Academy, he's on a mission to create impact, helping people gain valuable skills, build successful careers, and drive innovation. We are honored to have him with us today to share his expertise, inspire us, and guide us toward a future powered by knowledge and clean energy. Ladies and gentlemen, please join me in giving a warm welcome to Mr. Abisayo Folu Agoy. Please let's show some love in the comment as we unmute our mic and welcome Mr. Folu Abisayo.
Thank you very
Mr.
much.
Mr.
Thank you very much, Excellence. Thank you so much. Very happy to see everyone in person. I started my career in tech in the year 2020. A year after that, I got my first full-time role as a software engineer in a tech company based in the US. Now, my role required me to always have online meetings, regular online meetings. And because of that, you'd always need light 24/7. Now, I had to make sure that there was always light. So there was a particular time that we were having a meeting, and then that particular period, I was supposed to have a meeting, but then my battery was low and there wasn't light. Then I decided that I was going to put on the generator. Now, when I went to put on the generator, I was pulling the generator. It was in the middle of the night. I was pulling the generator, but it didn't come on. So I kept on trying and trying. And that particular night, I missed that meeting because of that. It was a very painful experience. And because of that, I missed the meeting, and that led me to decide to go into solar installation. Now, I knew then that it was either I fight for my career in tech, or I watch how the inadequate power supply of Nigeria snatched my passion out of my hand. That's why I founded Superverge Tech Solar Installations. It's a company that provides clean, renewable solar energy to homes and businesses across Nigeria. Now, in less than 3 years, we have installed solar system in over 50 homes and businesses and we are just getting started. We have helped tech bros and Cs to supply, we have helped them to become competitive in the global market because now they have 247 power supply with our solar installations. We've helped businesses increase their profits by removing the constant need to budget for fuel. Now, it brings me a great smile to my face when families don't have to worry about fuel prices and unreliable national grid. They can now enjoy 247 power supply. Now, aside all this, I feel that this particular skill is a knowledge that every single one of us should know, especially people staying in countries where there is limited power supply, because solar system is the future. That is one of the essence of this webinar. For a lot of us that want to start their career in tech, they can begin from here. That want to start a career in solar installation, they can begin from there. Many of us, we need the knowledge because maybe we already have a solar setup and then we need to know how to maintain it instead of spending huge amount of money on engineers to come and maintain your solar system. This webinar is for you. Or perhaps you just want to install your own solar setup and then you are skeptical about the kind of engineer you want to call into your home to come and check it, because some engineers will not give you the right products. So in this particular webinar, I'm going to teach you about different parts of the solar system, how to recognize an original product from that is not original. And so I really hope that each and every one of us, we ask a lot of questions, because I'm going to answer every one of the questions that has to do with solar system and installation. Thank you all so much, and I hope you enjoy a very lovely time in this particular session. All right. So can you see my screen? I'm going to share my screen now. Can you all hear me? Can you hear me?
Yes, sir. We can hear you, sir.
All right. Can you see my screen? Okay. All right. Now, before we begin, I want you all to log into this particular application, this particular software, www.slido.com. You can scan this QR code, and I just answer the question there. Let me see. Give me a second. So just all right. So you can, if you're already logged in, you just www.slido.com, just click on join as participants, or you can join with that code. If you have logged in, you can just comment in the chat section that I've already logged in the chat section that I've logged in. Just give us a few time before. Okay. A second. All right. I think Peculiar has logged in. Let me see. All right. So if you have logged in, you can just answer the question that is there. Okay, I should send the link to the group. Okay, let me see. Let me send the link. Give me a second. So I'm going to send the link to the group now. All right. So there is a question there. Question says, what are your thoughts on solar installation? What are your thoughts on solar system installation? What are your thoughts on solar system installation? All right, I'm seeing some responses. I'm going to share my screen now so that I can all see the responses. All right. So, what are your thoughts on solar system installation? Someone said it's reliable. Nigerian power life. It is impressive. Someone said decent is an alternative. It's a necessary. It's a necessity. Every remote worker needs it. Okay, these are very essential points. Okay. All right. So I know that many of us have questions to ask about solar system installation. So let us just continue the session and okay, it's the future. It has saved me from stress of depending on NEPA. It's upgrade, it's impressive. Very good. These are lovely comments. And that is true. You are all correct, really. Solar system is the future, not just in Nigeria, in every part of the world. It's renewable energy. It doesn't cause pollution. And it's something that every single part of the world is trying to lean into in the nearest future. Okay, so at this point, let me stop sharing now so that I can move into what we have for today. Let me share my slides. All right. Now, what is solar system? What is solar system? Can we all hear me? Can we see me? Okay. Now, solar system is derived from two keywords, namely solar, which means sun, and system. Solar system refers to a photovoltaic PV system designed to convert sunlight into electricity for residential, commercial, or industrial use. It consists of several interconnected components that generate, store, and distribute solar system efficiently. Solar energy efficiently. Now, there are key components of a solar system, and the following are the major components. Now, the first one is solar panels. Now, the regular people call it solar panels, but as engineers, we typically call it photovoltaic cells. So PV cell. So anytime you hear someone say PV cell, just know that most likely they're talking about a solar system, a solar panel. So the solar panel or a PV cell is also, they are the same thing really, they are interchangeable. Then we have the inverter, we have the battery, we have the charge controller, and then we have electrical wiring and protective appliances. Now, all these things outlined here, we are going to talk about them one after the other. Now, solar panels. Let's start with the solar panels, which is the key major components of the setting, which is the solar panel. Now, what are solar panels? Solar panels or solar modules. So, is that you call it solar panels, or you call them solar modules, or you call them PV cells. So, it essentially means the same thing. So, solar panels are devices that convert sunlight into electricity using photovoltaic cells. So, essentially, they take the sunlight from the sun, the visible light. You know, the sun brings a lot of electromagnetic rays, right? There's ultraviolet rays, there's visible light, there's infrared. There are so many rays that come out of the sun. The sun is rich in so many rays, right? We call them electromagnetic. So out of these rays, okay, please, can we, sorry, Miss Wura Blessing, please, can you mute yourself, please? Thank you. Okay. All right. Thank you so much. Can you all hear me? Can you also hear me? Okay. All right, cool. So what I'm saying is that the sun supplies a lot of radiation, which is known as electromagnetic radiations, right? Out of that radiation, we have ultraviolet rays, we have visible light, we have infrared radiation, and so many things like that. So what the solar module or the solar panel essentially does is that it converts this sunlight, this visible light, into electricity using what they call PV cell or photovoltaic cells. Now, they are a key component of a solar energy system commonly used for residential, commercial, and industrial power generation. Now, what are PV cells? PV cells are also known as solar cells. They are devices that convert sunlight directly into electricity through the photovoltaic effect, a process where light energy, which are photons, generates a flow of electrons. Now, photovoltaic cells are connected electrically in series. Now, if you look at the panel now, many of us have seen a panel. There are different types of panel. There are three major types of panel, but we're going to analyze them in detail, right? We're going to analyze them in detail. Now, if you look at the panel, you realize that each of them has what they call PV cells. They are all groups of cells organized in series, right? So if photovoltaic cells are connected electrically in series or parallel in circuit to produce higher voltages, current, and power levels. Photovoltaic modules consist of PV cell circuits sealed in an environmentally protective laminate and are the fundamental building blocks of PV systems. So each cell on a solar panel, each solar panel are made up of cells. Cells make up the solar system. They are building blocks, and these cells are arranged in series or in parallel, or series parallel, mostly series parallel. Now this will now determine the total voltage and the current, and also the power of that particular solar panel. Now, PV cells comes with positive and negative terminals. Each cell is 0.5 volts to 0.6 volts in capacity. So you can jotting it down so that in case maybe like I said. So just understand that each particular cell has about 0.5 volts. So it is now these volts that are in series that makes up the total voltage of a particular solar system. Now, a lot of customers normally ask us engineers that how durable is the solar system? Now, the solar system can last up to 33 years. It's very durable. And they always ask that, is it waterproof? Is it something that can easily melt? All these questions, is it something that can easily break? Now, the solar system is made to be very, very powerful. If you look at this particular setup, this talks about the major components of the solar system. We can see that the top part, you can see the frame, right? After the frame, that's what they call the module frame. Then we have the glass, right? Then after that glass, we have the encapsulant. Before you now have the solar cell. So you can see the 3-layer of protection that a typical solar panel have. And that's why the solar panels are very durable. In fact, it's so much so that even if the glass breaks, it still be working. So it is built like that. Its solar panel is so powerful that it's not so easily that a lightning strike can destroy it. It lasts that long. Even at times when a solar system is not properly put in place and maybe there's a thunder and maybe the thunder destroys maybe the inverter or some appliance in the home, you can see that the solar panel will still withstand it. So to show you how powerful it is, right? So after the solar cell, we have another encapsulant that the solar cell is sitting on. Then we have the back sheet before you have the junction box that contains the terminal. So this is the layer of protection that every solar system have. Now, how to read specifications in a solar panel. Now, these are essential in case you want to buy a solar panel, because we also see that a lot of customers normally ask us questions such as they ask us things like they want to set up a solar system. They now ask that, how many panels are you going to bring? How many panels do I need? And that is the question they ask. How many panels do I need? And we always tell them that it's not about the number of panels, but it's about the capacity. Do you understand what I'm talking about? For instance, two panels now, each of them 100 watts, 100 watts, and one panel which is 500 watts. Which one is higher in capacity of those two sets? Which one is higher in capacity? Anybody can answer it. I'm talking about two panels, each 100 watts, and then you have just one panel with 500 watts. Which of them is higher? Is it the two panels or the one panel? Which of them is higher in capacity? That's what I'm saying. Which of them will produce more current? Which one do you think? Anybody can answer the question. What did you say?
The one of 500.
Very good, Mr. Maxwell. The one of 500, that is it. So that's why anytime a customer asks us that, can I have like 2 panels or 3 panels? Well, like, it's not about the number of panels. What you should be asking is, what capacity of panel do I need? So if you need a system of 1,000 watts, we will not be able to divide, okay, 1,000 watts divided by how many panels I'll bring. So maybe that 1,000 watts now, we can divide it by 200 watts. So that means how many panels do we need? We need 5 of 200 watts panel. So this is how it is calculated. Do you understand? So that is how it is. But let us quickly look at it. Now, another thing you need to understand is you need to know how to study the nameplates of the panel system, right? the nameplate of the panel system. So we're going to analyze them one after the other. Do you get my point? So this is how it typically looks like. We can see the maximum power, the power tolerance, the maximum power voltage, maximum power current, open circuit voltage, short circuit voltage. All these things are written there for a reason. So we're going to analyze them one after the other. You see? Now, first of all, the maximum power. Now, what is the maximum power? Power is simply the total capacity of that particular panel. It's the total capacity of the panel, how many watts it supplies. So in this particular case, it is 275 watts. So that is the amount of power that is being released. That's the capacity of the panel. Now, the higher the watts, the stronger the panel. So you have 275, we have 300 watts, we have 400 watts, we have 445, we have 555. We even have some cases where we have 650 watts. So the higher the watts, the stronger the panel. So you're not looking at the size now, right? Although the power is directly proportional to the size, but what you are checking essentially is that power. So that means it can produce 275 watts in best conditions. Then the other one is the power tolerance. The power tolerance. Now, what did this mean essentially? It means this is the range of power that can be supplied by this panel. What does it mean? It means that this panel now that we're looking at, it's either, can we all see my pointer? Can we see this picture very well?
Yes, we can.
Okay, so this means that this particular panel, it can either be, we have a 0, and there is +3, 0 to +3%. What does it mean? It means that this panel can either be supplying a power of 3% more. You understand? But it cannot be less. It can never be less than 275. It means that it can either be more than 3%, but it cannot be less. In this particular case, sometimes it can be plus or minus. Sometimes it can be minus this plus this, but in this particular case, just +3%. It means that it can. So in some conditions, this panel can supply more. So which means that this panel is a very good panel. Do you understand? Then we also have what we call the maximum power voltage. The maximum power voltage. Now, you should understand that voltage is like, you know, when you're talking about electricity, the best way to the best analogy for electricity is just water. Now, water flowing through a pipe is very similar to electricity flowing through a wire or any given conductor. Now, the same way pressure is to that particular water, that is the same way voltage is to electricity. So voltage is the pressure, is the push. It drives the current. You understand? Now, so when I talk about the maximum power voltage, it is the working voltage when the solar panel is producing power. You understand? So current is like the flow, while voltage is like the push. You get my point? So then we have, let's now move to the maximum power current. Now, what's the maximum power current? Now, it is the working current of the solar. Now, in this particular scenario, the maximum power voltage is 32 volts, that is VMP. Then the maximum power current is 8.61 ampere. So voltage is measured in volts, current is measured in amps, right? Very good. Then what we call the VOC, which is the open circuit voltage. Now, this is the voltage that is being gotten when the panel is not connected to anything. Like the panel is not connected to any battery, any inverter, any setup. It is just there under the sun. So the voltage that is being produced at that instance is what is known as the open circuit voltage. Now we have what they call the short circuit voltage. Oh, please, are you all still listening to me? Are we all still listening? Yes. Hope I'm audible enough.
Yes, you are.
Okay. All right. Now we have what they call the short circuit voltage, short circuit current, which is ISC. Now, what is short circuit current? Now, this is the current that is being produced when the two terminals touch themselves. Now, please, this is dangerous. So please, as an engineer, you don't put negative and positive, you don't short circuit it. It can cause an explosive effect if care is not taken. You get? So it's dangerous. So the essence of this ISC, which is the short circuit current, is so that the engineers can be able to design the protection that is needed, maybe in terms of fuse and other protective devices. You understand? So this is the current that's being produced when the positive and negative terminal of the solar system of the panel is in direct contact to one another. You understand? Now we have what they call the nominal operating cell temperature. This is NOCT, nominal operating cell temperature. Now what does this mean? Now when the panel is working normally under the sun, now this shows how this is the temperature that the panel is going to be operating under. So this you can see that 45 plus or minus 2%. That is 45 degrees Celsius. It can either be more, maybe like that is it can be 47 degrees Celsius, or it can be that is 43 degrees Celsius. You understand? So that's just telling you that okay, when the panel is in operation, it can either be as high as plus 2%, that is plus 2 degrees Celsius, or lower than that. That means the range is 45 to 47, 43 to 45 to 47, that kind of range. You understand? Now, there's another thing I need to explain to you guys. Please, all these things you are learning, even if you don't want to become a solar engineer like me, but at least it will help you. Like maybe you want to install your own setup so that you'll be able to understand what the engineers are doing. So they won't do things that are wrong, because if a wrong setup can cause a lot of devastating effects in a household. Now, there's something called the maximum system voltage. Now, what's the maximum system voltage? This is the total number of panels. It gives you the total number of panels that can be series together. You understand? That can safely be connected. So the panels can be series to a whole lot, but it shouldn't exceed 1,000 volts. You understand? So you see some people, they want to create a lot of power. They begin to series, and if it exceeds 1,000 volts, a lot of terrible things can happen. It can cause electric shock. It can cause even a fire. So that's why they put this thing here, telling you that okay, series this panel, but anything that it should not exceed 1,000 volts. That's exactly what he's talking about. Now, the other one is the maximum series rating. The maximum series rating. Now, this is talking about when you're adding a fuse, it must not be more than this particular one. There's 16 amps. So your fuse shouldn't be more than this for protection. So you protect the panel from being damaged. Then also what they call the operating temperature. Now, this is telling you in what weather condition can the panel operate in. You get, although it shouldn't be too hot or too cold, but it's telling you this is the safe weather condition in which your panel can operate in. The safe weather condition in which your panel can operate in. So in this particular scenario now, it can operate in 85 degrees Celsius. It can also operate in negative 40 degrees Celsius. So in negative 40 degrees Celsius to 85 degrees Celsius, you get. So that is how it is. Then we have what they call the application class. Application class. Now, this particular one is talking about where it is mostly used for. Now, which particular, is it for industrial use? Is it used in the home, or is it used in restricted areas? So application class A simply means that it is safe for homes, it's safe for offices, and it's safe for buildings. As a matter of fact, class A in any gadget means the highest safety level. Then they also have what they call the fire class. The fire class. Now, this fire class tells you how resistant this particular this panel is to fire. How resistant, there are some things that are fireproof to an extent. So it tells you how resistant it is to fire in this particular context. Now, so in this particular one, now the fire class is C. So it means that it has some basic resistance. So class A is the highest, but in this particular one now, it is C. It means that it has basic level of protection. So then we have what the weights. In this particular scenario, it is 19 kilogram. Then we have what they call the standard temperature and pressure. Now, what does this tell you? This tells you in what particular conditions were these particular panels tested. In what particular conditions was it tested? Now, it was tested under perfect sunlight, cool temperature, and laboratory conditions. That is 1,000 meter. Then we have the atmospheric pressure of about 1.5, 250. That is 25 degrees Celsius. Now, so this is 1,000 watts per meter, and then this is all the standard temperature and pressure testing a particular solar setup. So these are the things that you should know when you are reading it. When that is how to read a particular panel. So these are some of the basic things that you should know about it. Then there are different types of solar modules. we have different types of solar modules. We have the monocrystalline, we have the polycrystalline, and we have the amorphous solar modules or solar panel. So in case maybe an engineer wants to install a solar system for you, you have to ask the engineer that which of the ones are you installing for me? Which of them? Are you installing the monocrystalline? Are you installing polycrystalline or amorphous? It's important because there are different types so that you know exactly what is obtainable in your solar system. So quickly, let's move to the monocrystalline solar module. The monocrystalline solar module. Now, what's the mono? I'm going to try to take it as effectively comprehensive as I can. At the same time, spend minimal time possible so that we can all get the information. I can ask as many questions as we want to ask. Now, what is a monocrystalline solar module? Now, monocrystalline solar model is the highest. When I mean highest in efficiency, you get monocrystalline solar module is the highest in efficiency. Now, it is made from a single pure silicon crystal, resulting in a uniform black or dark blue appearance. It's usually dark blue. Usually dark blue in nature. You get, and it has the highest efficiency of about 17% to 22%. Now, it is the most expensive. So yes. So at times, some engineers might want to cut costs. So if they want to give you a cheaper setup, they will most likely just go for the least expensive one, which is the polycrystalline. But we're coming there. But this is the most expensive, the most effective, the most efficient. And the manufacturing process involves a complex process, pulling a single large silicon crystal. Now, I want to tell you something. You can see that in the monocrystalline, you can see this diamond separator. You can see the diamond separator. Now, that's exactly how it is. This exactly is it. Now, this is exactly how you can identify a monocrystalline solar module. You can see the diamond separator here. This is it. So you can be able to identify so you can see it. So let's move on. They have the polycrystalline. You can see the polycrystalline. You can see the difference. This one, there's no diamond separator. You can see that it is just one line. You see? You can see that it is just line. So this is another example, and it's always sky blue. But let's analyze it together. Now, the polycrystalline solar module is made from multiple silicon crystal pigments melted together, resulting in a bluish hue, which is sky blue. It is slightly low. It has a slightly lower efficiency rate than the monocrystalline, usually around 15% to 17%. So it's not as efficient. It's more affordable. It's more cheaper than the monocrystalline. You get, so this one is more effective in the northern part of the country where the weather is very hot, because in places that is cloudy, it will not perform well like that. You get, so this one is mostly used in maybe all the solar fans, solar lights, so you can see. So guys, when you're looking at the roof of a building now, you'll be able to now know, okay, if you can be able to identify if this is a monocrystalline solar system, a polycrystalline solar system. You get, you can be able to identify it. Like I told you, the monocrystalline has a diamond separator, while the polycrystalline doesn't have it. Then the final one, although there are so many types, but the three major types, what I'm explaining to you now, right? So the final one is what they call the amorphous, which is the thin film solar module, the amorphous solar module. Now, this one is made from a thin film of non-crystalline silicon. Now, it has the lowest efficiency, right, compared to the monocrystalline and the polycrystalline. It's the least expensive. The surface is smooth and clear with no visible grid lines. Now, this particular one is mostly used in watches or calculator or maybe small power banks. You get, so that's how it is. So this is how it look like, guys. So this is a picture of the three of them. This one, the middle one is the monocrystalline, right? This one here is the polycrystalline. This one is the amorphous. So you can see how it looks like. You can see how it looks like. So this is how it is. Now, module array. What is a module array? Now, an array of modules consists of two or more PVCs. PVC, please, who can tell me what PVC is? Who can tell me what PVC is? Let me know if we have been following, please. I want to be very quick. At the same time, I want to make sure that we are all following. What does PVC mean? What does it mean? Anybody can just write it in the chat section quickly, or just unmute and say it out.
Photovoltaic cells.
Thank you, Mr. Hillary. It means photovoltaic cell or PVC, or you can call it solar module, or is what people call solar panel. But engineers, we don't call it solar module, or we call it PV cell. You get, so if an engineer is telling you the PV, just know what it means. Now, a module array consists of two or more PVCs wired to produce the required voltage and current. Now, there are three types. There's series connection, parallel connection, and series panel. Now, when you look at a roof, you see different panels. You can see like 10 panels or 20 panels or 21 panels. Now, they are not connected the same way. Two roofs can have 10 panels on them, but one of them can be connected in series, while the other one might be connected in parallel, and another one might be connected in series parallel. The essence of this connection is to supply the required number of voltage and current that is required for that particular household. You understand? So there are three types. We have the series connection, we have the parallel connection, and we have the series parallel. Now, in series connection, voltage is additive, current is constant. You understand? So in parallel connection, current is additive while voltage is constant, and in series parallel connection, you can get that one. Now, what does that mean? It means that let me give an instance now. If I have two panels, 12 volts each, and I connect them in series, if I have two panels, 12 volts, right? If I have two panels, 12 volts and 5 amps each, if I connect them in series, it means that I'm going to have 24 volts and 5 amps total. However, if I connect them in parallel, I'm going to have 12 volts and 10 amps total. Do you understand what I said? Did anybody understand? Do you understand what I just finished giving?
Yes, sir.
Yeah. Okay, now let me show this question. Let me show the question to the house. Let me show this question. Assuming I have 3 panels, please pay attention. I have 3 panels, 12 volts and 5 amps each. If I connect them in series, who can tell me the total voltage and the total current? You can just chat it in the chat. You cannot write it in the chat section. I have 3 panels. 12 volts, 5 amps each. If I connect them in series, what is the total amperes? What is the total voltage and what is the total amperes? Anybody? Just write it in the chat section. Quickly. I want to make sure that we're following. I want to make sure that I'm not talking too fast. I want to make sure that we're following. So anybody, let me write it in the chat. 12 volts, 5 amps, 3 panels. So who can tell me if I connect it in series, what is the total? Okay, somebody. Okay, I've written to. Okay, I can see somebody. Okay, Denzel, 36 volts, 5 amps. Very good. That is for series, Abby. Very good. What about for parallel? What would I get for parallel? Very good. Hilary too, 36 volts and 5 amps. Very excellent. Excellent. Very good. Yes. Yes. Okay. All right. So Denzel and Hilary too, 12 volts, 15 amps, because the current excellent. Very good. That means we are following. It shows that we are following. Very good. Excellent. So let's proceed. So we have gotten it now. So that's just how it is. You get. So in case maybe you want a particular capacity, you know how to combine it. Even though you might not necessarily need to even call an engineer, you can just know what to do. So let us quickly move to solar batteries. Let's just move to solar batteries. Now, definition, types, and uses. The definition, types, and uses. Now, all right. So now, solar batteries or battery storage systems store excess energy generated by solar panels for later use. Now, this is how it is now. What's the difference between, some people normally ask me questions such as, can I have my solar system without the battery? Can I just have only panel there, connected to the house? Or do I need an inverter? These are questions that people ask. So I need to teach you how the three of them work hand in hand to supply current to your household. Now, what is the essence of the battery? Now, I will tell you the essence of the battery. The battery's main goal is to store excess currents for future purpose. What does it mean? It means that now that there is sun, like in some parts of Nigeria, like in Lagos State now, there's sun. Where there's sun, if you look outside the window, you see a lot of sun there, right? So when you have a panel on your roof, right? So the panel, like I told you, the panel converts this sunlight into electricity. Now, this electricity, there are some that are excess, right? And in the night, there is no sun, and you might need to use power. So what does the battery do? The battery stores this excess current in itself. It keeps it for you, so that at night, or in maybe when it is cloudy or rainy or there is no sun, you can still have power. So that time that there is no sun, the battery will not be the one supplying current to your household. Do you understand? So there are 3 major types of batteries. We have the gel batteries, the tubular batteries, and we have the lithium-ion batteries. You get. We also have other batteries like the AGM battery. But the 3 major types we have are these 3 batteries. You get. These are the 3 major types. Now let us start with tubular batteries. Now, many of us, tubular batteries, number one, tubular batteries, what are the construction? It has the feature, it features a tubular positive plate, making them more robust and long-lasting than the flat plates. They typically have a lifespan of about 3 to 5 years with proper maintenance. So your battery can last up to 3 to 5 years. Now, charging time, it requires longer charging time compared to lithium-ion batteries. And it requires maintenance. Now, in the tubular batteries, tubular batteries, it is liquid in nature, it is not sealed. And so it gives off gases. You understand? So you need to be pouring water, you need to be maintaining it. You need to be maintaining by pouring some water on it regularly. Do you get my point? And so it's not good. It is suitable for residential and commercial applications with moderate power requirements, especially in areas with frequent power outages. Now, what are the disadvantages? It is heavier, it requires more maintenance, and have a shorter lifespan compared to lithium-ion battery. Another thing is that this battery is not preferable to be kept in the home because of it gives us gases. It is liquid in nature. So it's best kept outside so that you not inhale the gas. You get. So then we have what they call the. So you can see the picture. So you can see the picture of it. There lies a gel electrolyte, which is a semi-solid substance, eliminating the possibility of acid liquid. You get my point? So just give me a second. I think somebody has been having issues of joining. Let me see if I can quickly reach out. All right, let's continue. So the lifespan, this one has a lifespan of about 5 to 7 years, depending on usage. So this one lasts longer than the lithium-ion battery, and it's even more expensive than the it lasts longer than the tubular battery. That is the one I just explained. And this one, so it has a longer lifespan, right? So the charging time is similar to tubular batteries. This one is maintenance free and is leak proof, so it doesn't leak out any gas or any liquid. It doesn't leak out, it just sealed. So this one can be kept inside, it can be kept indoors because it is sealed. You understand? Now, application is suitable for places where maintenance is a challenge, such as remote areas, for applications where safety and environment concerns are priority. It's maintenance free, it is leak proof, and it's environmental friendly, but it's more expensive and low discharge rates than the tubular batteries. Now let's move to the next one. This one, it is the, permit me to use this word, it is the baba of all the baba. Yeah, okay now. But it is the highest in capacity, it is the highest in efficiency, and it is the highest in quality, right? And it's the highest in expense. It is more costly than the rest. You get that is what they call the lithium-ion battery. The lithium-ion battery, it can last up to 7 to 10 years, if not more. Right? It has a significantly faster charging time. It is 100% maintenance free. It is very compact. Very compact. You can keep it, it is smaller than the rest, but has the similar capacity, smaller size. It occupies lesser space. It is lightweight, high energy density, long lifespan, and fast charging. But the only disadvantage is that it is very expensive. So we have the solar inverters. Now, quickly, let's move to the solar inverters, definition, type, and uses. So any question we have, I will answer everything. So as you're learning, you can be jotting down your questions. Now, what are inverters? And this is the major issue that a lot of people mix it up. You get, so when you want to install your solar system in your house or maintain it, you will know the questions to ask your engineers. What are solar inverters? Solar inverter or solar panel is a crucial device. So solar inverter or solar panel inverter is a crucial device that converts the direct current power generated by solar panels into the alternating power that homes and businesses use. Now, what does it mean? Now, there are two major types of currents, right? We have what they call the AC current and the DC current. AC current is alternating current, DC current is direct current. Those are the two major types of currents. Now, the current that is coming from your generator is called an AC current, right? It is the current that supplies power to your home, that puts on your light bulb, that puts on your fan, that puts on your TV, that charges your devices for you. That is the AC current. Now, the DC current is the current that comes out of your battery. That is the DC current. It comes out of your battery for your phone or for your watch or for your laptop is the DC current. The solar panel also supplies DC currents. The DC currents. You get my point? And now, the DC current coming from your battery it cannot it cannot be used directly like that, because your bulb in your house need AC current, but your battery is supplying DC current. So the battery alone cannot put on your bulb in your house. If you carry your bulb now, the two terminals, and connect it to your battery, it's not going to on. It's not going to on because the battery is supplying DC current, except if it is a DC bulb. Except it's a DC bulb, but if it is not a DC bulb, it's not going to light at all. Why? Because it needs an AC current. So that is where the inverter comes in. So what the inverter does is that it converts the DC current coming from your battery, it converts it into AC current. That is why it will not supply to your whole house and everybody will not have lights. So note this, the current coming from your generator is an AC current, and the current coming from the Kanji dam, your transformer, is an AC current. So what the inverter basically does is that it converts the DC current from your battery into AC current so that you can be able to use it in your household to on your bulb, your fan, your TV, and use it normally. Without the inverter, you can't use that setup. So in case you're asking questions, can I buy the solar system without inverter? Without inverter, you won't be able to use that battery or that panel. Because so the inverter is one of the major significant part of the solar system. Do you understand? Now there are also types. Now you can learn that as I'm teaching all this, I'm teaching you the types. So when you want to install your solar system, you know what to tell the engineer. You ask the engineer, what type of inverter are you bringing for me? What type of charge controller are you bringing for me? What type of panel are you bringing for me? So you will know what is obtainable. You get, you know what is obtainable. At times, when you are seeing a solar system that is very, very cheap, you are excited about it. But at times, they might be bringing some instead of, for instance, now we learned 3 types of panel. We have just learned the batteries now, 3 types of batteries, right? And now we are learning 3 types of inverters. So all these things will tell you what is obtainable, right? Now let me just give you this caveat a little bit. Now there's some inverters that has charger inbuilt, which can charge your battery too. You understand? So there's some inverters like modern inverters, they have charger. So at times maybe some that is how some solar setup, maybe when there is lights, you can use electricity to charge your battery. So there's some inverters that has a charger inbuilt. Why there's some inverter that are just strictly only for converting DC to AC. So that is how it is. Now there are types of solar inverters. Solar inverters are classified by their output waveform with the 3 types. We have the pure sine wave, we have the modified sine wave, and we have the square wave. These are the 3 major types. Let's delve into it. Please, are we still learning? Are we still hearing me? Am I still audible? Are you seeing my screen? Am I talking too fast? Please let me know in the comment section if we are good to go. Are we good to go? Okay. Okay. All right. Thank you. You can't hear me. Thank you. Okay. Thank you. So I will try to hurry up so that we can all finish in time. You get, but at the same time, I want it to be as comprehensive as possible because this is a master class. I want each and every one of us that the moment we leave here, we start feeling like an engineer already. You get, and yeah, there are going to be certifications too. But they're going to be certificates. So now the first type, the first type is what we have, the pure sine wave inverter. Now the pure sine wave inverter. Now this one produces a smooth, continuous AC wave that closely resembles the power from a wall outlet. Power quality. It offers the highest power quality and is suitable for all types of electronic devices, including sensitive equipment like computers, audio equipment, and medical devices. Cost typically more expensive than modified sine wave. Now, the pure sine wave inverter is the highest category of inverters. It's very similar to it produces a current that is very similar to the current produced by your transformer. The transformer in your house, it is very similar. You get, so it is superior in quality, right? Now, understand this. Not all inverters can work for some particular appliance. There are some inverters that if you use it to a particular appliance, it can damage the appliance, especially some sensitive appliances. You understand? So the pure sine inverter is the superior. It produces superior power, superior current. You understand? Yes. Now, and also the most expensive too. Is the most expensive. So at times too, like I said, sometimes when engineers want to cut costs, instead of giving you pure sine wave, they will now give you maybe modified sine wave. So, but we'll now go to modified sine wave now. What are the advantages? It's superior power quality and reliability, suitable for all types of loads, minimal interference with sensitive electronics, and it's higher cost. So if you know that you have a lot of sensitive electronics, like for instance now, in medical laboratories, it's better use the pure sine wave because there are some sensitive electronic devices that are there that you need a superior power to it. And yeah, let's continue. On the next one, we have the modified sine wave. This one produces a stepped or square wave AC waveform. You can see I'm putting the picture there. So I know many of us as I'm teaching you, you are seeing the picture at the side. So this picture is exactly how it looks like in the home. So it's modified in the modified sine wave. It produces a stepped or square wave AC waveform that approximates a sine wave. It has a lower power quality than pure sine wave, but still suitable for most common appliances and devices. It is less expensive than pure sine wave. It has lower cost. So yeah, this one can put on common. So if you know that in your home you don't have much sensitive devices that are there, like medical devices, then you can use this one. You get, so it's less affordable. I mean, less affordable. You get. Now, so we have the disadvantages. It has lower power quality. It may not be suitable for sensitive electronic devices, and it may cause noise or malfunction in some devices. Then let's move to square wave inverters. Now, this waveform, it produces a simple square wave AC waveform. The power quality, it produces the lowest power quality, right? And it is the least expensive of the three types. What are the advantages? It has a very low cost. What are the disadvantages? It has a very low power quality. It's not suitable for most electronic devices, and it may damage sensitive equipment. So this is the least, it produces the least current in quality. So this is how it looks like. Now, this is how it looks like, the three of them, right? This one is the square wave. You can see how it looks like. This is the pure sine wave. You can see how it looks like. Very pure, like a sinusoidal flow. Why this one is the modified sine wave? You can see how it looks like. This is the kind of current it produces. All right, this is another major part of the solar system. The charge controllers. Now, what is a charge controller? A charge controller, also known as a charge regulator, is a device that regulates the voltage and current flowing from a solar panel to a battery, preventing overcharging and ensuring optimal battery performance and lifespan. Now, what are we saying? Now, at times, you know that the current, when it's coming from a panel, at times the sun can be very bright. While at times, maybe a cloud will cover the sun and then it's not as bright as it is, and then the current goes. So the voltage will be what? Fluctuating. So what the charge controller does is that it kind of stabilizes or regulates the voltage. That is one. So that number two thing that the charge controller does is that it prevents your battery from overcharging and undercharging. So at times, when your battery is full, right? If you keep on charging it, it can overcharge and can spoil or damage the battery. You get? It can spoil or damage the battery. So what the charge controller does is that the charge controller, it recognizes when the battery is already full, right? And then it stops charging it, right? And also it recognizes at times there's something called in the night. You see that in the night when there is no sun, at times the current can reverse. How many of you have experienced this many years ago? You know, all these old phones, when you are charging your phone and all of a sudden they take the lights, you will now see that your phone is still charging. How many of us have experienced that many years ago when we were using all those old phones that doesn't have all these diode, all these old phones? Okay, you can see Ms. Bisola recognizes. Any other person? Yes, Miss Oriande, yes. A lot of us, Hillary, yes. A lot of us have experienced it, yes. Those are those days. So it will still be charging. So you'll be thinking that it's still charging. So until you now disconnect it, then I first of all blow. You get, when you see low battery. What happened was that it was discharging, right? So at that point in time, the current was leaving up, because when they took the light, you see, there's something called, I told you that voltage is similar to what? Pressure, right? Voltage is the push that pushes the current, right? So now there's something called in electricity, there's something called potential difference. So current flows related to the potential difference between those systems. So it means that, you know, that normally in a system, for instance, in a system, let me put water now, because that is a very simple analogy. Water in a pipe. Water flows from a region of higher pressure, right, to a region of lower pressure. So if there's a higher pressure here, the water will flow this way, vice versa. Similarly to electricity. So with the higher voltage, when they take off the light, when the light is on, the voltage coming from your socket, your wall outlet, is higher than that of your battery. So it flows towards your battery. So the moment they take the light, the reverse is the case. your battery now has a higher voltage, so it flows out. So that's what they call discharge. You get, it's called a discharge. So that's why we notice in those days the phones that they were producing then that whenever the voltage drops, the current start to reverse. Why? Because the voltage is now reversing. It's going to a lower, from a higher voltage to a lower voltage. So now in this particular new system, there's something called the diode. The diode prevents that. The diode allows current to flow in only one direction. So it prevents the reverse. That is another importance of the charge controller in your system. Without the charge controller, in the night, all the current that your battery has preserved will just leave. It will go back to the panel. It will just go back. You just see that your battery just discharging. So, but because of the charge controller, the charge controller contains a device called a diode. So it prevents that reverse current. So that's why in the night, your battery power is still preserved and none is lost. You get? I hope you are following. Yeah. Now, let's now move to types of charge controller. Yeah, there are the two main types of charge controller we have. These are two main types. We have the pulse width modulation, and we have the maximum power point tracking. Now, with PMW being a simpler, more cost-effective option for smaller systems, and MPPT being more efficient and larger. Now, please understand this. The MPPT charge controller is the most expensive, right? While the PMW is the least expensive. You get? So you can see, and for instance, now you can see an PMW for 20,000 naira. Maybe for 30 amps PMW for 20,000 naira. You can see that same 30 amps MPPT. You can see it all the way from 60,000 naira. To show you this is how expensive it can get. I will tell you the reason why it's expensive now. Now let's start with the pulse width modulation charge controllers. I know that many of us have seen this picture before in some homes, in some solar installation setup in some homes. This pulse width modulation charge controllers. Now these controllers regulate charging process by switching the current between the solar panel and the battery, effectively controlling the flow of power. They are simpler and less expensive than the MPPT charge controllers. PMW charge controllers are suitable for smaller solar systems or applications where efficiency is the primary concern. PMW charge controllers force the panel to operate at the battery voltage, which is less efficient. Now, let me tell you how this one operates. You see, at times, the voltage coming from the sun can be very high. For instance, now, your battery might be 12 volts, right? And the voltage coming from the sun can be like 40 volts. So what this PMW does is that the PMW, it will throw away the remaining the power coming from the sun is like maybe the voltage coming from the sun is 40 volts, and then your battery is about 12 volts, right? So it's going to throw away the remaining 28 volts, or the remaining 30 volts. You get 38 volts, 28 volts. It shows those volts remaining. You get, in next one, I'm just telling you that it remains only that 12 volts. So the remaining, yes, I'm talking about the PMW. Are you still on the PMW? Is the PMW I'm displaying? Mr. Henry, is the PMW I'm displaying? Yes, exactly. So what I'm saying is that yes, exactly. So what I'm saying is that yes. So what I'm saying is that so what the PMW does is that it throws away the remaining 32 volts. You get? So the remaining voltage, it shall throw it away. So you are left with only that 12 volts. So it is not efficient enough. You get my point ahead. So it throws it away. Yes.
So I think it's PWM.
Thank you. Okay, PW. No, it's P. Okay, P.
No, you said PMW. You have the same PMW, so it's PWM. We're saying, yeah.
Okay, PWM. Okay. Yeah. Sorry for the mix-up. PMW, PWM, pulse width modulation, pulse. Yeah. So PWM. You get, so the PWM charge controller. I get my point. So that's exactly how it charges it. You get. So now let's now go to the MPPT charge controller, which is the maximum power points tracking charge controller. Now this one, you can see the charge controllers are designed to extract the maximum power from the solar panels by continuously adjusting the voltage and current to match the panel's maximum power points. They are more efficient than the PWM charge controllers, right? Particularly in situations with varying sunlight conditions or when using higher voltage solar panels. MPPT charge controllers are often used in large solar systems or where maximum energy capture is crucial. MPPT charge controllers can also handle solar arrays with a much higher voltage compared to the battery charging voltage. Now, what am I talking about? What's the difference between the PWM and the MPPT charge controller? Now, I told you something that for the PWM, when the voltage coming from the sun is 40 volts and your battery is 12 volts, what it does is that what the PWM does that it will just discard all the remaining 28 volts and it will only collect only the 12 volts for your battery. So there's a lot of wasted voltage. Do you understand? But for the MPPT charge controller, what the MPPT does is that the MPPT will be tracking it. Instead of throwing away the remaining 38 volts, it will convert that volt into currents. Do you get? So it converts the excess voltage into currents to charge your battery faster. That's why your MPPT charge your battery faster than the PWM. It is more efficient. So, and it is also more expensive than the PWM. Do you get? Do you understand? Do you understand what I just been explaining? Or do I repeat myself? Do you understand what I just said? Do you not see the difference between the PWM and the MPPT? So, so in case maybe you want to install your solar system, you ask your engineer, please, which charge controller are you bringing for me? Are you bringing the PWM or the MPPT? Do you understand? Can I move on? Do you understand what I just been explaining? Okay, you understand. Okay, cool. So let's move on. I want us to try to wrap up before 2:30. So what are the solar generators? Now, this one is just many of us hear of solar generators. Now, solar generation is just systems that has everything in one small box. So it's a system that has both the charge controller, the inverter, the battery, everything in one box. So they call it solar generator. And that's just the difference. So it's an all-in-one solution. Solar generators offer an all-in-one solution for power generation by integrating solar panels, a battery, and an inverter into a compact, portable system, providing clean and renewable electricity for various applications. So quickly, let's now move to the protective appliances. We are wrapping up already. Protective appliances, these are protective devices used to safeguard the solar system from excessive current or voltage caused by short circuits, overloads, or faulty connections, preventing damage to component and ensuring system safety. Yes, like yesterday, I went to a particular customer and they told me that the engineer that installed solar system for them, they told me that their solar system the inverter got damaged by lightning, by thunder. The thunder damaged the inverter. Why? Because number one, probably the apartment was not properly earthed, or there was no surge there. I mean, there was no surge there. Okay, so there are some protective devices that can prevent your solar system from damage, your inverter from electric shock, from different kind of they protect your system generally from high voltage, low voltage, over discharging or under discharging. So these are protective appliances. You get, so these things will prevent your solar system from being maybe from any thunder, lightning strike, or from overcharging or undercharging. You understand? So we're going to analyze a few of them now. Now we have the DC breaker. The DC breaker protects the DC side of the system, solar panels, from concurrent and short circuit, overcurrent and short circuit. Yes. So the DC breaker, you protect the charge controller at times when the current is too much coming from the sun. The DC breaker will just switch off. So the DC breaker is a good example. Then we have the AC breaker. It does the same thing, but this time around it protects the inverter, not the charge controller. So we call that an AC breaker. So it prevents overcurrent from destroying the inverters. You get? So it safeguards the AC side. You understand? Against overloads and faults. Then we have the voltage protector. So we normally call it AVS as well. So the voltage protector it protects your system, your inverter, from voltage spikes caused by lightning and grid functions. You get? So that also protects it. Then we have that in that particular appliance. Now they didn't have this voltage protector. This is another reason why the inverter must have damaged, the lightning must have damaged the inverter. They also have what they call the fuses. You understand? This provides overcurrent protection by breaking the circuit when excessive current flows. So you can attach these fuses to maybe you can attach them to your panel. When the panels are plenty, you can put the fuse to avoid maybe over current. They have what they call the residual current device or earth leakage circuit breakers. This one prevents electric shock by detecting leak current. So if there's a particular leakage in a particular part of the appliance, it will just immediately just switch off, disconnect the power, so nobody can be electrocuted. So these are some, look at them. I put the picture there so that we can all look at how it looks like. So this is a DC breaker. This is how a voltage protector looks like, because we also call it an AVS. This is an AC breaker. These are the fuses. Every panel usually comes with a fuse, so but yeah, it only comes with a fuse. Then this is the earth leakage circuit, earth leakage circuit breaker, or the residual current device. There are still other protective devices though. There's the MCB, you get the MCCB, the MCCB. There are so many other ones like that, but these are the most common one. You get it. Okay, this is where we're going to draw the curtain. I believe I've been able to talk about the solar panel, the charge controller, the inverter, the protective devices, solar generators, and many more things like that. So with this particular knowledge, I know that we have gotten the essential fundamentals to begin a career in solar system engineering, or to become more knowledgeable on how to maintain your solar setup, or how to be able to direct engineers to do a proper installation on your home or your business or your offices. At this point in time, do you have any questions to ask? So I think I will take it back to the host to take over from here. Host, please, are you there?
Yes, please. Thank you so much, Mr. Bisayo. Please, I would like us to celebrate our guest speaker. I mean, you'd agree with me that this has been an insightful learning. If you gained one or two things from this lecture, please celebrate our guest speaker. It's not common to have this, profound knowledge for free without paying a dime. Let's celebrate him, please. Let's celebrate the company, the brand, Superverge Tech. Let's celebrate the brand. I'm sure that we learned a lot of things, a lot about solars. I'm sure we learned a lot about solars. We learned about battery, solar panels. We learned about, a whole lot, how to read specifications in solar panels, types of solar modules, and everything. Now, this is the time that we have all been waiting for. I don't know if you have questions. I'm sure that as explanatory as the lecture has been, we might have some questions I would like to ask. Some questions. If you have questions, please indicate by raising up your hands, either in comment section or just using an emoji. Okay, I think I can see that some people have questions. Some people have their hands raised up. Oviade. Okay. So Oviade says he has a question. So please, I think he said he even has questions. So Oviade, please, can you unmute yourself and ask your questions? Simsola says, I don't miss, so sorry. You know that I know many of us would have thought would have started African time in quotes, but no, we don't do that here. We don't do that here. Oriade, please, can you unmute yourself and ask your question? Thank you.
Good afternoon, in the house.
Good afternoon.
Yes, my question is that, please, I want to ask about this type of diode. That this is our host talk about diode. Hello.
Okay. Yes, please. Please, could you take the question again? Guest speaker, are you on the call?
Yeah, I can hear you, Mr.
Okay, please take the question again.
Okay. My question is, what is the function of a diode? You talk about diode. Hello.
All right. You are asking the question, what's the function of a diode?
Yes, a diode. Like I have just 3 questions. So the first one is that, yes, like the function of a diode, 1, and number 2, you talk about parallel, like parallels and series. So my question is that it does all those all those this thing, solar panel, like it depends on how it depends on maybe the function of the thing. That's how we can use parallel or series. You understand? Or series parallel. Is it for everything, or it depends on how much we use it about? That's the second question. Do you understand the question?
Okay, so I got the first question, but the second one, you said that the parallel and series, is it dependent on what, please?
Yeah, like depending on maybe the function of what we want to use. Like you know that for example, like, let me ask, like maybe I want to install a panel, maybe just for like maybe for just shop. Example, like maybe for just shop, maybe in that shop where we only have maybe in that shop maybe just only freezer. You understand? So my question is not that is it because of that freezer, is it are we going to use maybe parallel for it just because of only freezer, or maybe something that is very, or maybe you want to use something that is very bigger than freezer? That's where we can use maybe series or different. So that's just my question.
All right, I understood that second one, Mr. Ayomide. Then the third one.
Okay, sir. So the third one is that, so you mentioned about AC AC and DC. So you mentioned of something. So I want to ask one question. You mentioned of battery is DC.
Yeah, I'm
I,
listening. I'm
can you hear me?
listening.
You said battery is DC. So and I want to ask a question. What about this our torchlight that we do use? All those lamp that we do use to charge. So if we use it to charge, maybe we charge it with AC voltage. What is the outcome of that? Is it AC to AC, or is it DC to DC? You understand what I'm trying to say? Maybe for example like this, maybe this generator like this that we are using. You said that the generator is AC voltage. So and this our torch that we do use, all those lamps that we do use at home, all those lamps that use battery. So my question is that can we use DC to charge DC? Maybe all those, because for me, because as you mentioned that battery is for DC, and you know that all these torchlight they are DC. So if you use DC to charge DC, what is the outcome? You understand? So that's just a question.
All right, you're saying if you can use DC to charge DC, you're talking about touch lights that have batteries. Is it like all this
Yeah,
your
that yeah
nice
yeah is that
dry cell battery?
yeah that is it DC or AC? So my question is that can we now use DC to charge DC?
Okay. All right. Okay, these are good questions, Mr. Ayomide. Very, very nice questions. Okay. Let me start with the first question. You said what's the function of the diode? Although I talked
Yes, sir.
about it, but I guess maybe at that point, maybe you zoned off. But you see, a diode prevents current from moving. I explained to you that at times when you plug your panel directly to the battery now, right? In the night, something can happen. In the night, current that the battery have stored might reverse to the panel. You get, and it will be discharging. That's what they call discharge, to be discharging. That's how you don't realize that even if you're not using your battery, you should still be going low. What does it call? And I gave an example of those phones of many years ago that when they take the light, the phone will still be charging. You'll be thinking that the thing is charging until maybe you now disconnect it, you now see battery low shut down. What happened was that the phone was discharging at that point. So what the diode does is that the diode prevents that from happening by making sure that current flows in only one direction. So anytime the current wants to flow in the reverse, it will stop it. This way, every charge controller has it in it. This way, your battery current is preserved. That is why your battery, even in the night, even if you don't use your battery in the night, the current will still be intact. But without that diode, in the night, the battery will be discharging back to the panel. Why? Because the voltage of the battery, at that point, the potential difference of the battery is higher than that of the panel. So it will reverse charge. So the diode prevents that from happening. Do you understand?
Okay, sir.
Exactly. That is the first question. Have I answered your first question now?
Yeah, I've answered it.
Yeah, very good. Now, the second one, you asked that series and parallel connection, is it determined by what you want to use the solar to do, like the function? For instance, is it that
Yes.
if I'm charging a fridge, I will use series? Why if I want to power a fridge rather, I will use series. But if I want to power maybe my fan, I will use parallel. Is that the question you're asking, right?
Yeah, that's my question.
Okay, so the short answer, the answer is no. It is not determined by what you want to power. It is determined by the voltage and current you want to get. That is one. You get, for instance, and there are so many things that will determine in this particular context. At times, you might want to get, for instance, if for instance now you have two panels, 12 volts each, or let me not use panel, let me use battery. If you have two batteries, 12 volts each, and that particular system, your inverter is 24 volts, and you know that your battery, your inverter, your panel, your charge controller, all of them should be in the same volts. Now, if you have an inverter that is 24 volts and you have two batteries, 12 volts, let me ask you this question, Mr. Ayomide. Are you going to series it or are you going to parallel the battery, and why?
Please, can you repeat the question, sir?
Okay, before I repeat that question, let me ask. In series connection, is the voltage additive or constant?
In series connection.
Yes.
So the current is what that is addictive.
No.
So why the voltage?
No. Let me repeat. No. Let me repeat myself. Okay. See, in series, you can write it down, please. Everybody, please write this thing down. Please write it somewhere. In series connection, the voltage is additive, while current is constant. Do you get? So, but in parallel connection, the current is additive and the voltage is constant. Please, have you all written it down? Please write it so you don't forget. Have you gotten it now? Have you gotten it? Now, I'm not asking you a question. I'm not asking you a question without knowledge now. Assuming you are an engineer, you go to a site, and the inverter that the client or the customer has is a 24 volt inverter, and you have two batteries, each of them are 12 volts. How do you do it? Will you series the battery or parallel the battery, and why?
Please, sir. Question. I just write this what you just told me now, so I want to write it again.
Should I repeat? Okay, what do you want to write?
Like this addictive and constant that I talking about. Because like in series, you say current is the one that is addictive, right?
Voltage is no. I'm typing in the chat section. In series, voltage is additive. Current is constant. Current is constant. In parallel, current is additive. Voltage is constant. It's constant. So I sent it in the chat section. Have you seen it?
Yes, sir. I've seen it, sir.
Okay, very good. So now, let me now take back the question. Anybody can help me to answer, Sha. Now I'm saying that as an engineer, you go to a particular home, and the inverter they have is a 24 volts inverter system, right? And they have two batteries. Each of them are 12 volts. How are you going to series the battery, or are you going to parallel the battery, and why?
I think I will.
Yeah? You what? Tell me.
I will parallel the battery. Parallel it.
You will parallel the battery.
Yes, sir.
Okay. Not. Why will you parallel the battery?
Because the panel you say is 24 volts, right? So and the battery we have 12 volts. So
yes.
for us to get the accurate thing, like to get the accurate, so that both of them can be compatible, I think parallel.
But if you parallel it, I said current is constant when you parallel. Current is when you parallel it, series is constant, voltage is constant, current is additive. So it means that even when you parallel the battery, you're going to still get a 12 volt system. So the person that got the correct answer is Mr. Dan Ebolaji. Not Mr. Dan Ebolaji. It is Denzel and Mr. Henry. They are correct. You have to series the system. Why? Because you want a 24 volts So 12 plus 12 is 24. So you series it to give you that 24 volts. Do you understand?
Okay, I just saw that. Yes, I just understand now. Mm,
Exactly. But in
yes.
case if it is a 12 volt inverter, you will parallel it. You get so with series and parallel is determined by the voltage and the current you want to get from that system. It's not determined by maybe you want to on freezer or you want to on fan. No, that one is determined by capacity of inverter, capacity of battery. But the series and parallel connection is determined by the voltage and current that you want to obtain from that your setup. Do you understand?
Yes, sir.
Very good. Then have I answered the three questions now?
No, the last question about the DC and the AC that I talked about. So my last question that I asked, I said
Okay, yes.
the
So
first,
yeah, you told me that.
can we use DC to charge DC?
Yeah, so please, host, please. Some people are asking questions in the chat section. Please hope you are taking notes.
Yes, yes, yes.
Okay, just take note of them. So that after Mr. We'll move to the other ones. Okay, so he was asking a question that what is the effect of using DC to charge DC and AC to charge AC? What's the effect? Anyway, the truth is that Mr. Ayomide, that's the only way system operates. Even your charger that you are using to charge your phone, do you know what the charger essentially does? It will convert the AC current that's coming from your wall outlet into DC for your phone to use. So that's what the charger does, because your the battery that is the battery, your phone battery is a DC. You get, so it can only be charged by a DC. So it essentially does that. Your charger just typically converts the AC current into DC current, and that's why you cannot just directly plug your phone into the socket like that with the wire. It will explode your phone. So what the charger does essentially, it converts the AC current into DC current and into your battery for it to charge. You get, so then
Yep.
so that is how it works. So DC always charges DC. You get my point? So every battery, and there is no, in fact, let me just tell you something. Everything that is charged is already DC already. As long as it is contained, as long as it's the essential capability of that particular system is to withhold current, it is a DC device. So your battery, they are DC. All batteries are DC. You get, then AC, example of something that supply AC is your transformer and your generator. Like, you know how you normally to do you don't charge generator. Do you charge generator? No, you put fuel, you put engine oil. For the transformer, you use the water coming from the Kanji dam. That's what they call hydroelectric power supply. That will not come into the transformer. The transformer will step it down. You get, but anything that has to do with charging, I'm charging my phone, I'm charging my laptop, I'm charging my phone, my touch, everything is DC, is essentially DC. That is why it's able to store that current. And what a charger does, in essence, it converts the AC coming from your wall outlet into DC that is now charging that particular appliance. So DC always charges DC, not the other way around. Do you understand?
Okay. Thank you, sir. Okay.
Yeah.
I understand now.
Thank you so
Yeah.
much, Oriade, for your questions. I know that I've learned one or two things from his questions so far. So we have other people that have their hands raised for further questions. Please, if you have your questions answered, either by the previous person that asked the question, please, if you already have your question answered, you can put your hands down. Thank you. So moving on, we have Oluseson. Oluseson, I think, did you type your question? Because I want to also read out the questions that are typed in the chat box. Okay, so Oluseson, please, can you go ahead to ask your question or questions? And then Oriade, please, can you put your hand down so that I will know those that are yet to have their questions answered. Please
Okay,
go ahead.
Thank you, the host.
Yeah.
And I want to say special thank you to Mr. Bisayo, if I'm correct. That was a very good session, very insightful and very educative for me. So I believe it is for everyone of us that joined this webinar. You have answered most of virtually everything I had on my mind through the responses you gave to the last person that asked the question. But what I just want, I think, is more to the host. I want to ask this session, because while the section was going on, I was having a bit of glitches at times, and so there were some areas that I missed. I want to ask if this webinar will be available for us to go over immediately after this session, so that we can have a better grasp of what was taught us today. Thank you. That's my question.
Okay, yes, the webinar is actually being recorded, and then we will try our best to get it across to as many people that want it after the class. Is that answered?
Yeah. So I say,
Okay.
Willem, just I need it. Please send
Okay.
it to me. Yeah. Thank you.
All right, no problem. No problem. Thank
Bye.
you. Okay, yes, please. So we have Helen. Helen, you have your hands raised. Can you unmute yourself and ask your questions or question? Helen, are you on the call? Okay, since we are not able to get through to Helen, we're going to move on. Gracie Ellis, if I got that correctly. Gracie Ellis, can you unmute yourself and ask your question?
Okay.
Or like I said, if you already have your questions answered by the previous questions asked, then you can put your hands down.
So I just want to say a big thank you to Mr. Bisayo for this seminar. It was really educative. So my question is a bit confusing because I'm confused about this. So I want to ask, what's the difference between panel efficiency and system efficiency? Because it's a bit confusing for me. So that's my question. Sir, did you get that?
Yeah, okay.
Okay.
You asked what is the difference between panel
Between
efficiency
panel
and
efficiency and system efficiency, yes.
Okay, that is a very good question, Ms. Grace. Now, panel is panel and system. System can be anything, right? System is any components that are working together to perform a function. You have computer system, we have solar system, we have circulatory system. System is just a general term. So when you're talking about system efficiency, the engineer might be referring to the whole system put together.
Okay.
You get?
Yes.
For instance, a system that has a good, I taught two different types of charge controller, different types of inverter. So imagine I want a very powerful system now. I get the most expensive type of charge controller, the most expensive type of inverter, the most expensive type of panel, the most expensive gadgets, right? And I put it in my home. And another person come and get the most cheapest, maybe the cheapest type of inverter, cheapest type of charge controller, cheapest. Now, which of the two homes do you think will be more efficient? Which of the two systems do you think will be more efficient among the two people?
The system.
Let me repeat myself.
Okay, please get yourself. Please.
I'm telling you that.
Okay.
System refers to different components coming together to perform a given function.
Okay.
So your charge controller, your inverter, your panel, and your protective device, everything comes together to make up a solar system.
Okay.
Very good. Now, I'm telling you that imagine somebody, maybe a particular home, they decide to buy I know I taught two different types of inverter. There's the pure sine wave, there's the modified sine wave, and there's the square wave. Now the person decides to buy the most expensive panel, the most expensive inverter, the most expensive charge controller for their homes, right? And somebody else chooses to buy the most cheapest inverter, the most cheapest panel, the most cheapest charge controller. I'm using the most cheapest, but just cheapest. I'm just trying to be exaggerating. So I'm saying that in those two scenarios, which of the solar system in quotes will be more efficient?
The more expensive one, obviously.
Exactly.
Yes.
Very good. And so somebody said something. Mr. Oluseson said the costlier, the more efficient. The more expensive one, very good. So that's one thing you should consider.
Okay.
The costlier of, when I mean costly, I'm talking about high efficient gadgets. You get, for instance, now instead of, you get a monocrystalline panel, you get an MPPT charge controller, you get a hybrid inverter, and you now get a lithium-ion battery. I trust me. In fact, your system is going to be very efficient because everything is working fine. It's charging, battery charging fast. Yeah. So, but if you now get maybe a PWM charge controller, you get a polycrystalline solar panel, you get maybe a modified sine inverter. You understand that the efficiency will not be as high. Do you get my point? So that is talking about
Okay.
system efficiency. System
Okay,
as a
so
whole.
okay, okay,
That one is
okay,
system. When I say system efficiency, we're talking about the
okay,
system as a whole, the solar system as a
okay,
whole, as an
okay,
entity. Now, get.
okay,
But when we're talking
okay.
about yes, when we're talking about panel efficiency, we're talking about
Okay, sir.
only in relation to panels.
Okay, okay, sir.
Do you understand now?
Yes, I get it. I get it.
And
I get it.
so there is panel efficiency, there is battery efficiency, there is charge controller efficiency. All of them individually have their own efficiency. But when they now come together as a whole to perform a given function, which is to supply power to your house, it is now called system, which is system efficiency.
Okay, sir. What you're trying to say now, the system is like broader and it's like it contains everything, but the panel is just like a singular kind of thing. Okay, I get it now. I get it.
Yes. Exactly.
Thank you, sir. Thank you, sir.
Yes,
Okay,
yes,
thank
you're
you
welcome.
very much.
Pleasure.
So now I'll be going to the comment section to read out the questions we have there. Oladele, are you still on the call? Please ensure that if you have questions you want to ask or you've typed it out down in the comment section, ensure that you're still on the call so that when the questions are being answered, you are there to listen to the answers. So he's asking, if I want an engineer to install solar power for my residence, how can I calculate along with the engineer all that I need to ensure he's providing all accessories in the right specification? Do I go over it again? Guest speaker. Or
yes, I got it.
Okay.
Yes. So if I want an engineer to install solar power for my residence, how can I calculate along with the engineer all that I need to ensure he's providing all accessories in the right specification? Very good. This is a very good question, and I like this question. Now she wants to be able to properly monitor our engineers to make sure that they don't give, or he, sorry, I think is a he. So he wants to be able to monitor his engineers to make sure that they don't maybe give him stuff, or they don't maybe there's something called wrong quotation. At times you can give a wrong quotation, and that's why some solar system they will complain that it's not working, it cannot on, it's not only after 2 hours it's just off because the engineer probably gave you a wrong quotation or wrong appliance altogether. Now what we do is this. Number one thing you have to do is this: you will calculate all the wattage of your entire appliances that you are using. Your fan, what is the wattage? How will you know the wattage? Every appliance has a nameplate at the back where they put the wattage there. If it is not there, just Google the specification online. This fan, this is the name of the fan, blah blah blah. Maybe you are using a particular brand of fan. I'm using this brand of fan. What is the power rating? So you calculate all the power rating. For instance, all the power rating can be like 1,000 watts. So you should know that any inverter that is giving you, let's assume maybe you are consuming a total wattage of 1,000 watts in your home. You should now know that any inverter that you are giving should not be anything less than about 1,500 watts inverter. Because if it gives you anything less than that, that inverter will not carry it. So you should give you a quotation that is not less than 1.5, that is 1,500 watts or 1.5 kVA inverter. Do you get my point? So that one is for the inverter. And then there are other things. Superverge Tech, we built a mobile application whereby it's easy for you to just input your total wattage and to give you everything, the total battery capacity, because there are actually functions for each and every one of them. You get total battery capacity. So that the application is still being built, and when it is done, you will publish. For now, don't understand that about the inverter. You get, and then just make sure that the panels. And so you now determine the panels. Like for the panels, just know that okay, they are of 3 types. So you ask him, is best you get a monocrystalline solar panel. You should get a monocrystalline solar panel. That is one. Then also the charge controller too. Preferably you can get a MPPT, but if maybe they are on budget, you can settle for PWM. You get, but preferable an MPPT charge controller. Then please make sure that you get you a brand new battery. Very essential, because it's not really the best decision to get a battery that have been used already, because a battery has lifespan. So your engineer should get a brand new battery. Even if you are using an inverter that have been used or other devices that have been used, the battery should be brand new so it will last longer. Because, but although, like I said, if your budget doesn't permit, you can settle for all these things. But I'm just giving you optimal solution. You get my point? So all these things you put in, like I said, there's a particular application that we built because there are deep calculations. To be honest with you, it might not be in this. It might not be easy for me to start teaching you now because the calculation is quite lengthy. You need that all of them have their formulas and everything, so it might be complex. But actually, we built an application that you just input the wattage there to give you everything. Yeah. So hopefully by this month, next month, before the end of next month, the application will be ready. So it's going to be in the public. So we download the application, just put in your total wattage like I taught you how to do it. It will give you both the capacity of battery to get, the capacity of charge controller to get, and the capacity of inverter to get. Everything will be there for you. Do you understand?
Right. Moving forward. Thank you, Oladele, for that accolades. So I'm going to be reading out a question from Sierra. Sierra says, "Good day, Engineer Abisayo. May I ask if the battery installed in solar panels be replaced panels?"
Panels, like panels.
Okay.
Maybe she wants to
Sorry
write
about
panels.
that. Okay. Okay. I'm also trying to understand the question. Okay. Can the battery installed in solar panels be replaced, or is the panel itself finished once the battery is broken? And based on the types of the battery you presented, which is the best batteries to use when it comes to replacement? Guest speaker, do you understand the question clearly?
Yes. So she asked the question, like these are like 3 questions in one. The first question she asked is that the battery installed in solar panels, can it be replaced? Or is the panel itself finished once the battery is broken? Or does it mean that maybe maybe the panel becomes useless if the battery is broken? Right? Then based on the types of battery, which is the best battery to use when it comes to replacement? Okay, this is a very good question. Now let me answer it. Now, firstly, yes, the battery can be replaced at times. In fact, usually you see a panel can last for the next 33 years. The panel can last for long, right? But the battery, every battery has a lifespan. Some batteries lifespan is 5 years, some 7 years, some 10 years, some 15 years. Like lithium-ion battery now can last up to 15 years. So a battery can be replaced. When the battery stops functioning as it was functioning initially, you got it, you can choose to replace them. But one thing you should know is that when you're replacing, for instance, if you have 2 batteries and you have used the 2 batteries for like 2 years and one of them stops functioning, or maybe for 3 years and one of them stops functioning, please just replace the 2 of them. Don't replace one and leave one. If not, that's new one is going to just get damaged. So it's good, you must always replace all of them at the same time. That's one thing. Don't replace them one by one, especially if you have used them for a significantly long period of time. Do you understand? Now, the panel is, once the battery gets faulty, when the battery gets faulty, the panel is still working fine. Panel does not spoil because the battery spoils. So that is one of the beauty of solar system. You can replace each of the components. At times, the charge controller, if the charge controller has issues, you can replace only the charge controller. If the battery has issues, you can replace only the batteries. If the panel has issues, you can replace only, although most likely the panel will not have issues because panels are very durable. You get very rarely can you see a panel have issue, but in case, you can always replace the panel. Then she now asks that which is the best battery to use when it comes to replacement. Now, the truth is that it depends on your type of question. When you talk about replacement, are you talking about in terms of costs or durability? Now, in terms of durability, the best battery is lithium-ion battery. Lithium-ion battery is the most durable. You get so then followed by gel and then tubular battery. Another thing is maintenance. Gel battery and lithium-ion battery do not need maintenance, but tubular battery need to be maintained. I mean, you need to be adding distilled water every once in a while. You get. So what I will just tell you now is that the 3 of them can be replaced, right? But the most costly is lithium-ion battery. Lithium-ion battery lasts longer, but it's just that when you're replacing it, you know that you need to spend a significant amount of money. However, for instance, now a lithium-ion battery can last up to 10 to 15 years, right? After that 15 years, you need to replace it. Maybe the lifespan has been exceeded. You will spend a significant amount of money because of the cost. But for gel and tubular battery, they last for about maybe 3 to 5 or 7 years. After that 5 or 7 years, you need to replace them, but you will not spend as much. So if it is durability you're looking for, you know that lithium battery is the best. But if it is cost effectiveness, gel battery and tubular battery are less costly. You get my point? So it's easy to buy them than lithium-ion battery. But lithium-ion battery lasts longer than gel battery and tubular batteries. Do you understand? Okay, so that is it.
Okay, Ciara, please, if your question has been answered, you can just give us a thumbs up. Moving on, would go to the next question on the chat section. Helen John, she's asking, what did you call the total number of panels that can be seried together? What did you call the total?
Very good question. Now it's called a maximum system voltage. Maximum system voltage. So that is the total number of panels you can series in terms of voltage now. So if the panels, you combine all the system voltage together, if it exceeds that maximum power voltage, there's a problem. It must not exceed it. So that's what it's called.
Okay. You're welcome, Sarah. Sarah says, thank you so much for the clarification. It's really enlightened me. Sorry for the typo and wrong grammar. Okay. Thank you so much, Sarah. Then moving on, we have okay. Esther is asking, sir, if I want to solar a bungalow fully, what's the best voltage to get for the house? If I want to solar a bungalow fully, what's the best voltage to get for the house?
All right, that's a very good question. Now, you want a particular solar system. What is the voltage you get for the house? Now, that's what so many customers normally is to ask. That what is the best voltage? What is the best voltage? Okay, for instance, now they normally ask that, okay, I have a bungalow, I have a flat, I have a story building. What's the capacity of solar panel? What is capacity of solar system I need? Now, please understand this. A bungalow can be small, but inside a bungalow there can be coffee machine, 2 deep freezers, 5 AC, right? And a story building might be big, but inside the story building only bulb is there. Which of them do you think we need a higher capacity of solar panel? I mean, solar system. Which of them do you think? Which of them do you think?
I think you want to answer that, Esther. Are you still on the call?
No, anybody can answer.
Okay,
guys,
to the house.
It's an interactive system. Which one do you think we need a higher capacity of solar? The bungalow that has deep freezer, 2 deep freezers, 5 AC, and 1 pumping machine, and the story building that just have bulbs and 1 fan. Which one do you think we need a higher capacity of solar system?
Okay, that of the 2 freezer.
The bungalow. So it's not about the size of the house. Very good, Mr. Maxwell. It's not about the size of the house. It's about what you are powering. So what you should ask is that I am powering just a fan, a TV, and a bulb. What capacity of solar system do I need? Do you get my point? So if it is, for instance, now if it's just maybe TV and fan, right, and maybe some bulbs you are powering in a bungalow, you can use a 1 kVA system. 1 kVA system is enough. You get my point? But if you are powering freezers, maybe pumping machine, then you can consider getting maybe a 6 kVA system or 3.5 or 4 kVA system, as the case may be. Do you understand?
Okay, so Esther says yes. Okay, the question has been fully answered. Moving on, let's go to the question asked by okay, I think this is Olu Sesson again. So he's asking, can we calculate our wattage if we have just the current and voltage, but not the wattage of the gadget or appliance stated directly from P equals IV? Do you get the question, guest speaker?
Yes, that's a very, very good and intelligent question you asked. In some cases, when you are checking the wattage of your appliance, they might not give you the wattage there straight. They might give you just the current and the voltage. So you will now multiply both of them to get the wattage of that particular appliance when sizing your house.
Okay.
So yes, you are correct. I multiply both of them.
Okay. Moving on, we'll go to the question asked by okay, still from the same person. Where do we get the app or software the guest speaker said would be available next month, specifying the ratings of the different components of a solar system from? She's basically asking where to get the app built by Superverge Tech.
calculate.
Yes. So the application is being built, and when we will launch it, it's going to be available on App Store and Play Store. You understand? So you download it from App Store, Play Store. So now our engineers are building it. So in let's say February ending, it will be released, and each and every one of you will get an email. So you can download it from App Store, Play Store. So you can be able to size your home appliances by yourself. So the application will tell you, when you put your total wattage, the application will tell you the capacity of inverter to get, capacity of battery to get, capacity of tractor to get, capacity of panel to get, and tell you everything you need to get. So you just show your engineer, and your engineer will just do the needful. You understand?
Okay, all right, beautiful. I believe that has been beautifully answered. Moving on, the number. Okay, I think it's also send notifications or. Okay, so he's still saying that please also send notifications to our email addresses when the app is available. Many thanks. All right, so I think that will be all for the questions in the chat section. If you still have pending questions, can you unmute yourself and ask your question? If not, we'll just move on to the other item on the program agenda. On the program rather. If you still have questions that are yet unanswered, you can unmute yourself and then please do ask your questions. I mean, that's why we're here. We're here to expand our knowledge and gain more insights about this thing called solar installation. Okay. Since there are no more questions, we'll be moving on to the next item or agenda on the program. And that should be the quiz. That should be the quiz section.
All right. Yes. Please, host, tell them that there's going to be prizes for people first, second, and third that wins that gets it correctly. So there'll be prizes for the first, second, third. So
yes, of course.
The prize, the winners will be announced after Engineer Kelvin comes to talk about it from here.
Yes, of course. You all know how we do it here. You all know how we do our quizzes. You would always get your prizes after the event has been ended. So please do well to answer the right question. Do well to answer rightly, and then expect your prizes after. That's for the winners after the program has ended. So let's move ahead to the quiz section.
All right. So thank you so much, host Ipsola. So to participate in the quiz, you just go to www.quiz.com/join. Then you enter with this code or just scan the QR code. So I'm waiting for you to join. So you can enter with the code 182206 or just scan the QR code to join the quiz so that we can begin. So the winner is going to be the first, second, and third by giving gifts to the first, second, and third. And also after this particular session, everybody gets certificates of participation. So if you join this webinar and listen throughout, you are entitled to a certificate from the company. Okay. Have we all joined? Okay, we are about to start now. We have one person. I think this is Clara.
I'm sorry, I'm still finding it difficult to get it.
Okay, just go to www.quizzes. Quizzes is QUIZIZZ.com/join. I put it in the chat section. So the moment you get there, you will put in the code. The code is 182206. And then after putting in the code, you'll be required to sign up or sign in. Then you can start playing. It's also called Playground. So let me see if another person have joined. So the moment 3 people join, we just start immediately. Only 1 person has joined now. Or the moment 4 persons join, we just start immediately. Only 1 person has joined.
I'm actually saying something like 12 school, business, corporate, college, executive, I think it's bigger than, I don't know. It's very good for
Sorry.
me.
Okay, no,
It's
it's
So I'm
not
saying
just
something like,
nice.
how will you use your week round? K-12 school, business, corporate, college, university, am I on the wrong side?
okay. Is it on the site? No, just click on the QR code. The code is 182206. Just click on the link www.squeezy.com/join. I put it in the chat section. Just click it.
Okay.
The code is 182206. 182206. So let me see if anybody has joined. So we have 2 persons have joined now. This is getting interesting. 2 persons have joined. Just 2 more persons and we'll kick off. Just 2 more persons. So we'll start immediately. Let us see the first, second, and third are going to get awarded in this session. Okay. 3 persons have joined. We have 3 of them. Okay, that is nice. 1 more person and we will start. 1 more person will start. But it doesn't mean that you cannot keep on joining, but I just want us to just conserve time. So if we are 4, the 5th person can come and win all of them. Don't say that because they're not 4, you don't have to join. No, just try to join. You might even end up overtaking the entire 4. Okay, we are 4 now. Are we starting? Okay, 5. Okay, we are starting the quiz in. Let me see.
Okay.
I think it's advisable that everybody joins the quiz. You know, it sticks better when you have this quiz backed up with the lecture. So let everybody join the quiz. We have over 27 participants on this call. So if we can all join the quiz, we'll benefit from it. Just forget about the prizes now. Let's just stick to what we're going to get, the knowledge we're going to derive from joining the quiz.
Yeah, exactly. Please try it. So I'm going to start in about 2 maybe 2 seconds now. Let me just share my screen. Give me a minute. Let me share my screen now. So give me a second. We're starting now. So we have like, but let's just start now. So we have, let me count the people that we have now. We have about 8 people now. So let me share my screen now. So can you all see my screen?
Yes, I can. I can see your screen.
Okay, so I'm going to start. Should I click on the start button now? Should I start? Host, you can tell me when to start.
Okay, please, you can go ahead now.
All right, so let's go. 3, 2, 1.
We have 2 more minutes to round up the quiz. So if you are still able to join, you can still join. We still have a few minutes to join. 2 more minutes left to round up the quiz. Let's answer as many questions as we can. The most important, let's answer them first. Let's go. 2 more minutes to round up. 2 more minutes to round up. 2 more minutes to round up. I said earlier, let's focus on the questions. Let's focus on answering the questions correctly, not about the prize. One more minute to go. Let's go. Let's go. 1 more minute to go, and then we round up quiz. 1 more minute to go, and then we round up the quiz. Just a minute to go. For those who find it difficult to be on the quiz, to be logged into the quiz section, we're sorry about this. It could be a network issue. I'm sure that it will be better next time. So 1 more minute to go, and then call it off. 1 more minute to go. 1 more minute to go. 1 more minute to go. All right, we have come to the end of the quiz. We have come to the end of the quiz. Please, if you are sure that you participated in the quiz section, give yourself a round of applause. Celebrate yourself. It's not easy. It's not easy. I know I can feel the heat from here. The questions are a lot. But yes, you made it this far. It's worth celebrating. It's worth celebrating. So do I still have my co-host on the call? You'd have the winners announced as we progress. We're going to the end of the program, so you have the winners. We'll have the winners announced to you as we progress. So be rest assured. And for the first, second, and third winners, you will be going home with a beautiful prize. Co-host, please, can you do the honors of moving on to the next item on the program?
All right. Thank you very much, my host. Okay, so now we are going to introduce Mr. Kelvin, one of the senior developers of Superverge Tech, to come and talk about the companies and its offerings. Mr. Kelvin, please, you have the floor. Thank you, sir.
Please, let's celebrate Mr. Kelvin. It's not easy to be a senior developer in the organization. Let's celebrate Mr. Kelvin.
All right, thank you very much, Excellence. Thank you very much, Bisola. Thank you very much. Good afternoon, everybody. Good afternoon. Am I audible?
Good
Yeah,
afternoon. Good
yeah, we
afternoon.
can hear you, sir.
All right, thank you very much. Yeah, so just like I was introduced, right? My name is Kelvin. I am a senior software engineer at Superverge Tech, right? The organizing company for this program. Yeah, once again, thank you all for being here, and I must say we have learned a lot today. And I hope we would all apply this one way or the other. Yes. All right. 1 second. All right. Am I still audible?
Yes, we
Yes,
can.
sir, we can hear you.
Yes, we can. Yes, we can hear you loud and clear.
All right. Thank you. All right. So today, basically, right, I'm just here to talk to you about what we do here at Superverge Tech and how we can be of help to you and your business, right? So first of all, right, Superverge Tech, we are a we're a technology company focused at helping people boost their business through digital solutions and of course renewable energy to make your business and your life better, right? At Supervet Tech, we focus on building mobile applications, websites, we design UI UX, we manage social media for businesses, also search engine optimization, solar energy solutions, and also we have the Superverge Tech Academy. So I would move forward to talk more on this. Please can we move to the next slide? All right, now Superverge Tech, we provide innovative solution, right, to all your businesses and also to individuals. So we're not limited to businesses. If you are, as a person, if you want to have tech services for your house, your personal life, we also cater to everybody. All right, let's continue. All right, so at Superverge Tech, our mission is to is to be the leading tech partner and foster growth through technology. So we want to be the first thing that comes to your mind whenever you think of getting a tech solution for yourself or for your business. And I'm very sure that we are on the right track on doing that. All right, let's continue. Right. So as well, just like I mentioned, right, we as Superverge Tech, we help businesses and individuals build mobile applications, right? So we can build mobile applications for your business or for your for your personal self, right? So if you need to put your business on the internet, if for example you run a market, you run a shop, and you want people to be able to buy and sell using an app, you can reach out to us, Superverge Tech, and we'll build an app for you that your customers can easily download and shop from your store, right? Continue. Yeah, so also like I said, with Superverge, we also help you build websites for your business. So the same thing, if for example you run a shop or you sell something and you want your customers to be able to order online, which will be very easier for them. So you can just reach out to us and we'll deliver a stunning and very, very fast website where customers can come and view your products and also buy and sell safely and securely. So we're not only limited to buy and sell, right? Whatever business you do, whatever industry you are in, Superverge Tech can help you deliver a solid website to help you boost your sales and your commission in the industry. Yeah, let's continue. Yeah, so I'm also joining to that, we also offer excellence UI UX design. That is, we design apps, design website, also design graphics for you. So your graphics, your flyers, your logos. So for your businesses, you can always reach out to Superverge Tech for that. Let's continue. Yeah, so just like I mentioned, we also help business and individuals manage their social media. So if you have a business or you're starting up a business, right? And these days your business has to be on social media. So you can reach out to us at Superverge Tech. We'll help you manage your social media, such as your Instagram, your Facebook, your TikTok, your WhatsApp. We'll help you manage it so that we'll reply to your customers very fast for you, help you post content, and just help you manage the whole stress of social media so that you can focus on building your business. Yeah, let's continue. Yeah, so just like we have done on this wonderful webinar, right? As Superverge Tech, we also offer solar installations, right? So we just taught uh how to install solar. So if you also want to install solar for in your houses, in your businesses, in your offices, right? So now that we have taught you how to do it, things to look out for, you can also reach out to us to come and install it for you, since you already know what to look out for, and we are sure to work with you, and so that you can use your knowledge, right? All the things you've learned on this webinar, right? You can also use it as you call us to install for you. We'll guide you through the process, and you see that everything you learned here is what happens as we install for you, right? So we are the best for you to reach out to for your solar installations. Yeah, so to the second part of what we offer, so that as Superverge Technologies, we have the Superverge Tech Academy. Right. So at Superverge Tech Academy, right, we nurture talents to foster growth, right, through hands-on training in the following areas. So that means we teach people mobile app development, website development, UI UX design, digital marketing, and graphic design solutions, right? So we help businesses and just individuals. We help train people on all these services, right? So if you're conversant with our Superverge Tech, right, you notice that recently Superverge was contacted by the Lagos State government, right, to teach digital marketing at an empowerment program lately. So you see that we Superverge Tech, we also provide this services to businesses of different scale. So no matter how large or how small a business is, we offer training to you on digital marketing, or even to train your staff on digital marketing, or to train you as business owner on how to do these things, right? All right, let's continue. Right. So when you choose Superverge, these are the things you get, right? You get a customer-centric approach, right? That means whatever we do in Superverge Tech is focused on you. Whatever we do, whatever goal we do, as long as you reach out to us, everything is centered about you. You are the main focus in company, right? Now, also, we are also very, very, very innovative, right? So we are driven by innovation. So we want to always build new solutions, bring out the uh new ways of doing things and apply them to your businesses, right? And we also have the best expertise available at Superverge Technologies. All our staff and our management is the absolute best in the industry. So you are sure that you have the best of the best in the industry. Yeah, let's continue. Right. So on your screen you have how to contact us. So you can just maybe you can screenshot the number on the screen right now, or you can check out our website. Just go to www.superverge.com. Right. You can just go there to check out our services more, and you can also reach out to us on info@supervergetech.com. So I urge everyone to please just go to www.supervergetech.com, and yeah, just reach out to us, and we'll be ready to reply you. Let's continue. Yeah. So thank you very much for having me, and once again, thank you very much for being here. I'm sure everybody must have learned one or two things, and yeah, we can't wait to hear from you at Superverge Tech. I will personally be waiting for everybody to just reach out to us so that we can give one of our these services to your business and help you just grow. Right. Thank you very much.
All right, Mr. Kelvin, thank you very much for the information about the company. We're really happy. Okay, everyone can see now that Superverge Tech is global. Yeah, we are global, and we don't just do just solar. We also do websites, mobile applications that help your business and your brand scale higher and better. All right, so if you have any question regarding our company, you can put it in the comments, or you can unmute your mic. Yeah, if you have any questions, maybe okay, what services do you render? We can take it again. So if you have any questions, you can just signify. All right, Miss Helen, your hands is up. Can you unmute your mic, please? Miss Helen. All right, all right. I don't think so. If there's no question, I'll be passing the mic back to my host. Host, please, you have the floor, ma'am.
All right, thank you so much, Excellence. We are wrapping up this beautiful webinar, and what we have next on our agenda is announcement of the winners. Before we announce the winners, I'd like us to just share in the comment section how the quiz went. Was it so tough? Was it easy? Was it something that we could easily chew? And then, I mean, it did not. We did not. Was it easy? Was it hard? Was it tough? Let me know how the quiz went. Let me know how the quiz went. Just type it in the comment section. Was it challenging? Yes. Was it so tough that this one broke me? This one choke. Did it choke? Okay, Sarah says it was challenging. This feedback will also help us so that we know the next steps to take when certain quizzes like this in the future. Okay, Helen just said it was tough, not that tough. Okay, Denzel said, I thought there was a time frame, so I was hurrying. Overall, it was nice. The teacher taught well. Okay, yes. But maybe next time would indicate the time frame so that you can work with the time. Okay. Hilary says it was making my adrenaline pump faster. The time. Okay, next time we'll try to give you the time frame, the exact time you're expected to stop, so that you don't have a rush of adrenaline when you are answering the questions. Esther said, I just did pick one. She said, I just did pick one, two because of time. So she did tubu. She did guesswork, right? I understand the time. So I think many complaints here was time. It's time rather. Sorry, time. Bolaji says it was challenging. I hurried thinking it was timed, but number 10 look into it. I was right, but it marked me wrong. Okay, you had a problem with the maybe a technical issue, right? He said you it was right. You ticked the right answer, but it marked you wrong. Okay, we'll look into that. We'll look into that after this program. Then Olu Sesson says it was interesting, but I don't know why the answer was PMW. I thought the host corrected that in the session as PWM. Okay. Maybe there'll be a bonus for that. I think the guest speaker is still on the call, so I'm sure that there should be a bonus for that. And then so it's PWM. I think Daniel Bolaji is asking, is it PMW or PW? It's BWM. I think that was addressed during the lecture. I think I noticed that I made mention of it. It's PWM, please, everybody, not PMW. Yes, thank you, Denzel. Okay, thank you so much for your PWM. Yes, correct. Thank you, Lucas. Thank you so much for your feedback. Trust us to work on the areas that you had challenges with in the next time you have a webinar like this. Now, this is the time that we have all been waiting for, right? The winners. Okay, so I would move quickly. I will start with the person that came third position. As I mentioned this person name, please give the person a round of applause. It wasn't easy. For third position, we have Denzel Ikebudu. Please let us appreciate him with our favorite emojis. Like I said, I know it was tough, it was challenging, it was everything, it choked. But then yes, it came out third position. It's worth celebrating, right? It's worth celebrating. Thank you so much for the show of love to Denzel. Then we have second position. The amiable personality that came second in our very beautiful quiz is Daniel Bolaji. Daniel Bolaji, please let's celebrate Daniel Bolaji. I think he was one of the people that said he had a rush of adrenaline, if I'm correct. Okay, he said it was challenging. Yeah, okay. Oh, okay, it was challenging, yes, but you scaled through. Congratulations to you. And then the winner of this quiz is no other person than Hilary Ogudu. Hilary Ogudu came first. Please let us celebrate the winner. Let's celebrate the winner. Let's celebrate him. So we have I'll go over it again. Then Denzel Ikebudu third. We have Daniel Bolaji second, and then we have Hilary Ogudu as first position. So now I'm going to in order to claim your prizes, that's for the winners particularly. I mean, we all did well. Everybody did well. For you to have attempted this quiz, it shows that you are ready to learn and then put what you have learned into use. So congratulations to everybody that was on the quiz that participated. I will be putting a number on the comment section right now. This is for the winners to claim their prizes. So reach out to this number as soon as this call is over to claim your prizes. I think someone is asking a question. Please give me a minute. Let me just quickly place this. Okay, yeah. So Olusesan is saying, please let us know what. Oh, okay. You want to know the. Oh, okay. Because of time, we might not be able to state everybody's score, right? But then I think I'll work with the technical team on how to get, the scores, everybody's grades, and then you can reach out to the same number, and they'll say, okay, said just first three. Technical team, are you there? Do we have? Right. Can we do that?
So just first three. The score is displayed, so we all can see the score. So it's there now. You can see
okay, beautiful,
but everybody performed wonderfully well. That's for sure. Everybody performed wonderfully well. You understand? So I mean, we see the highest here. The highest would have gotten. I mean, the highest would have gotten 10%, 10 points. That's question 2. He was correct. It's supposed to be PWM, so that is an issue there. But the person have gotten 10 points, but he got about 10 points regardless. So this is the first 3, and it's also determined by who got there first. You guess, not just about how many people got 80%. Who was the first to get 80%? So it's also determined by this. So that's how you have it in hierarchy. So we can see that although Denzel and Kiara, they got 80%, but Denzel is the third position because he got there first before Kiara. So do you now see the analysis? Yes. Okay, yeah, a lot of people got 80%. Yeah, a lot of people have gotten 10%, 90% because of that PWM. So there's going to be added 10 points to each and every one of you because of that issue. Yeah. Yeah. So yeah. So but the first 3 positions, the first 3. Okay, let's do it this way. The first So the first 3 positions reach out to that number on the screen for their prize. Yes, exactly. That is how early people finish. Yes. So this particular screen here, the WhatsApp line that the host shared to the group chats, just reach out to that particular WhatsApp contact and state your name. if you're among the first 3, you're going to get a prize, a bonus. Yeah, so over to the host now.
Okay, so do we have that settled already? Is everybody happy? Oh, okay. Someone is saying I had 90% in a nutshell. So you're actually calculating. That's good. I love that. I love the way we are all involved in this quiz. This one is by fire by force. I must get my mark that I'm supposed to get, no less. Violence. Yes. Okay. Okay. Right. So just do as the guest speaker has rightly said. Right. I believe we are all happy now. We are all settled. Nobody was cheated. Okay, so moving forward, okay.
Yeah, all right. Okay, you know what? Even everybody that participated at all, just reach out for a prize you get. Although the prize,
Yay.
everybody get a prize. You understand?
Yay.
So as long as the
I
participation,
think we should
you are going to get
celebrate
the
the
prize.
company, celebrate the brand. Now
Yeah, so
everybody
just
gets
reach
a
out to that
prize.
line. Everybody gets a prize. Yeah. So reach out to the line.
Wow.
But the first, second, and third, reach out to, so you get the prize, special prize. Then every other person gets prizes too as well.
Capacity. Yeah. Somebody say capacity. Somebody say power. Yes. Yes, so that settles it. Everybody gets a prize, and then there are special prizes for the first, second, and third position. Thank you, Superverge Tech. Thank you, Superverge Tech. Moving, yes, thank you, Ciara, for saying Esther. Thank you, Rebecca. Thank you. Moving forward, yes, so we want to advise so now I know we had questions pertaining certificates, during the at the beginning, the commencement of this webinar, right? So now, time to address that question. If you want to get your certificate for being a part of this class, and then you also have people that were part of the class, but along the line, maybe they went to use the restroom and they didn't come back again, or they went to eat their lunch and they didn't return again, please inform them to chat up the official WhatsApp number of the brand, the official WhatsApp number of Superverge Tech, so that you can be told what to do on how to attain your certificate. You cannot be in this class. You cannot wait for 1 hour, 2 hours, close to 3 hours,
So,
and not have
sorry,
a certificate. Okay, yes, please
so,
go ahead.
So everybody gets, as long as you attended this webinar, you get certificates. So, but for you to claim your certificate, you need to follow at least one of our accounts. So this is our account. You use this link on the screen. This link that is on the screen. That is linktr.ee/Superverge Tech. So you will take it to, we are on TikTok, we are on Instagram, we are on Facebook, we are on LinkedIn, we are on Twitter. So you choose the account that is conducive for you to follow. So when you follow one of our accounts, you send the screenshots to that WhatsApp line that you have as an evidence that you are following an account, and then you'll be awarded your certificates free. Yeah.
Okay, yes. So you can see the WhatsApp number clearly displayed, right? So just do that. Follow one of the accounts and then send a screenshot of that. Then send it to the WhatsApp number. You can see displayed clearly on the screen. Are we clear with that right now? Are we all clear with that? Okay, thank you so much. Moving forward, we have come to the final stage of this webinar. Celebrate yourselves. Thank you. We'll be calling on the MD CEO, the icon of knowledge, the brain behind the brand Superverge Tech, to give his closing remark. Please celebrate the MD CEO. Celebrate the MD CEO. He is a well of knowledge that is open, accessible to everyone that wants to draw from. Let's celebrate the MD CEO.
All right, thank you
You
so
have the
much.
floor now.
Thank you so much, Ms. Bisola. Thank you. I want to appreciate each and every one of us that joined. I want to appreciate Mrs. Helen, John, that is my big auntie. Special thanks for you joining this particular call. Then I want to appreciate Miss Kiara, Domino. I think she joined from Philippines. Thank you so much for being present in today's webinar. I want to appreciate Mr. Daniel Bolaji, Mr. Denzel Ikebudu, Miss Esther, Excellence, our host. Thank you so much for joining. Miss Bisola, our second host. Thank you so much for joining this call. I want to appreciate. Special thanks goes to my sister Miss Busola. Thank you for joining. Thank you for joining. And then my dad, special thanks goes to my dad, Mr. Folusho Adedo Inagoy. Thank you so much for joining. I'm so grateful for the encouragement. Miss Grace, Mr. Hillary, thank you. My mom is also on the call, Mrs. Ibuku Agoy. Thank you so much, Mr. Oloseson Otolorin. Thank you so much, Miss Rebecca Ase. Thank you so much for joining the call. And many of you, I know many of you still to the end. Then we have Mr. Samuel Henny. Thank you so much, Mr. Abayomi. Thank you so much. And many of you that were unable to, maybe you're so busy, but you joined initially, but maybe you couldn't stay to the end. I want to appreciate you. Thank you all. And I hope and I believe that with this knowledge, many of you are already on your way to become a solar engineer. And even if you don't want to pursue that career as a solar engineer, you'll be better informed. You'll be well knowledgeable in solar system installation as to maintain your solar setup on your own without spending much money on solar engineers. And also, you can also, when you want to install your own solar setup, you can easily direct them. So without much ado, but all of you are entitled to a certificate, a free certificate. So what you just do to claim your certificate is this: you would follow at least one of our accounts. Either you follow our Facebook account, follow our Instagram account or TikTok account if you're not following. So the account is on the screen. This linktr.ee/Superverge Tech. It will take you to all the accounts we have. Just click on any one of them. You can click on our Facebook account or Twitter account or our LinkedIn account or our TikTok account, Instagram account. So follow it and send a screenshot to that WhatsApp line 0 +234 074 464 1360. So you send a screenshot to that WhatsApp line stating that you're already following it, and then you are going to be you will get your certificate. And as many of you that won prizes as well, please reach out to that same line on WhatsApp, and then you are going to be awarded prizes. So the first, second, and third, reach out to get a special package. Then each and every one of us, as long as you attended this webinar, you also get packages as well, you get prizes as well. So thank you all so much once again. I wish you all the best. At this point, call it a day. Thank you. I'm going to see you in our next webinar, other sessions and training program. And then I wish each and every one of us the best. Thank you. Bye.
Thank you and have a beautiful day ahead.